Okay, let's go ahead and get ourselves started again. Okay, what we are going to do is continue down the path of going ahead and getting multiple parameters out of the model and ultimately computing a ratio between those different parameters. So we're going to try and get some sort of efficiency. And again, just sort of computing a ratio between two simple values is kind of a simple way to try to come up with an optimum based on two different values. We can start getting much more interesting and complex, because we can put together all sorts of different functions that say, given 2 or 3 or 4 or 5 different values, what is the best way to determine the optimum out of all these different inputs? And there's a lot of different schemes. In fact, a lot of good research going on right here in the building relative to how you actually consider multiple different objectives and kind of come up with what you consider to be the overall best. So let's pop back in, if I can find it. There we go. To Revit, and we'll take a look at this custom node and really the logic behind it. So again, here are the values that got reported out. Let's go ahead and take a look at how it's constructed. So if I go back over here to the beginning, I really didn't do too much to go through and change this. I really just went through and added there was gross floor area. We were taking care of that. I added gross surface area. Okay, but I did need to go through and kind of change my function around just a little bit, because my function for going through and computing these things only really took into effect that one parameter. We wanted to actually take into account two different parameters now. So what I'll do is, let me close this. I'm going to open up the starting point just so we can sort of build it together. Okay, see, so we can make sense of that. So here's the idea. We got this is where we were at the end of the first example. We really had this Revit model thing. It's basically taking in a single parameter, reporting a single parameter. We're looking okay. We need to go through and kind of adjust this a little bit. So here's how we go through and adjust it. Okay, we need to kind of put in just a couple more inputs, just so we have some more data we need to pull out. So what I'm going to do is just say that the parameter report, let me copy that and paste that down. As opposed to just gross floor area, I want to put in there the gross surface area. And that's just giving it an idea of really, hey, what is it that we're trying to pull out? That part's looking good. Our Revit function over here, it's looking pretty good, but we need to go through and incorporate this new value into it, because right now this Revit function, or this Dynamo function, is really only grabbing the single report parameter. Okay, let's go ahead and kind of put the second one in there. And how we're going to do that is just take that node, and we're going to edit the node, and just adjust it a little bit. So here's the idea. Over here in this custom node, we have the input parameter to change. That's going to stay just the same. The value to test, that's going to stay the same too. We're going to go through those different rotations. The parameter report, ooh, that looks interesting. I think that's the one we're going to change around a little bit. Because what I'm going to do is actually put 2 of these in here. And what I'll even do is I'll just call it parameter report 1. And I'll copy that and put in there the parameter report 2. Okay, so I just got 2 different parameters I want to put in there. Let me do a save as. I'm going to say just 2 values right here. I want to keep the original one around too. I don't want to mess that one up. Okay, I basically have 2 slots to put things into. Parameter report 1, parameter report 2. We're ready to start using those. So here's what we got to do. If you take a look at the logic behind this, it starts by just setting the element parameter. Okay, so based on the parameter to change the radius, set it, go to Revit, post it. Okay, that's going to stay the same. Second thing we do is we get the element parameter, and we go ahead and get the parameter report 1 and say, great, let's grab that from Revit. let's go ahead and actually do something very similar. Okay. Let's go through and say that not only do we want to get relative or element parameter, the first one, we actually want to get the second one too. Okay. So what can we do? We can say basically let's grab that node. What I'm going to do, I'm going to still grab the same element, but for the parameter report, I'm going to pull in 2 as opposed to the first one. Okay, that's going to get the value right there. Let me go ahead and I'm going to do the transaction again also, just to make sure that it executes in the proper order. Next, I'm going to go through and do some sort of scaling. It's going to actually be the same scaling function. Since it's both areas, I can just grab that same formula and just copy that down. Only this time, as opposed to putting in the value of the first parameter, I'm going to put in the value for the second parameter. Okay, so now I got sort of 2 side by side. Input must be connected. I think that's going to be okay. So now I'm going to basically have 2 different values. So value from report parameter 1, value from report parameter 2. Sort of makes sense so far? Okay, no worries. Next thing we got to do is that CSV string. That CSV string is all about writing out 2 values. Okay, now I'm going to get 2 things back, so I need to write out 3 values instead, so not to worry. Let's go ahead and I'm going to basically edit that one too. I'm going to save this as I put B in there just because I already made one earlier. Okay, what would a 3 function 1 look like? Okay, the first 2 function 1 takes data value 1, put this comma in there, data value 2. If I want to make it a 3 value string, I'm going to copy that, put data value 3 in here. Again, I have to kind of take that number and make it a nice string, so it'll kind of pop out as a nice string value. And what I'm going to do is going to concatenate those strings together so that after data value 2, put another comma in there, and then finally put the 3rd string in there. Okay, so let's pause there for a second. How did that feel? And that went by really quick, but yeah, good. The first one here, that's actually just putting a carriage return. So since the last one just sort of ended at the end of a line, the carriage return says, okay, go ahead and start a new line. So start a new line, put in the first value, put a comma, put the second value, put a comma, put the 3rd value, but sort of stay on the same line. So that's actually just a carriage return. Yes?
How are you going to save it? Does it make it automatically whenever you add the things? Like it stays between?
Oh, it won't actually put a space in there. So if you actually wanted to put a space in, that's very good. Same sort of thing. You would basically say string. Okay. And I'd type a space. Now, that's very unintuitive because you can't see the space there. But if I wanted to go ahead and put that space in, I concatenate it in. Exactly. Exactly. So I know, isn't that weird looking? But it looks like this. So over here, thank you for asking. You know, it's funny because there's all these things that are counterintuitive, and everyone's wondering the same thing. You're like, what is that? And it's a carriage return. I was wanting to put it in character 13 or character 9 or some ASCII code or something like that, but no, it's a carriage return. Okay, so can you see that this is going to take data value 1, going to put a carriage return, data value 1, comma, data value 2. Then I'm just using the same comma again, then data value 3. Does that make sense? Great. Let's go ahead and save that away. Let's roll back over to this function. I got write a CSV string 2 values. Well, that's kind of okay, but I need to get our 3 value function in here. See if I have it in here somewhere. Actually, what I should do, I changed the name. I should be good. And say, okay, I should not only change the name, let me change its properties, because you really want it to be, you know, kind of proper and show up in the list nicely and all those good things. So it's like write neatly. It's one of those things. Okay, so I got that there. Now when I come back over here, it'll show up in the list and it'll look nice. So what am I going to do? I'm going to say, great. Let's still take the first value. The first value is just the input value. So I'm just going to, basically the value to test. That's all I'm putting in for the first value. The second value is the result of the first parameter. The third value is the result of the second parameter. Okay. Now I can get rid of that guy over there. So I got this beautiful looking string here for this new row. This part over here, concatenate the string, that just says, hey, take whatever used to be in the file and throw this new line at the tail end of it. So it basically just reads the file, and then we're going to concatenate, we're just going to add your new string right to the end of it. Beautiful. And now we basically have a function that's going to go through and perform for those 2 different values. Now, this little output here, that's just my little way of saying, hey, go ahead and show me what the string is. It's going to perform those things and write the file, but if I actually just want to sort of see what it is, what I can do is just connect it to the output. That way I can sort of see what that is as a string value. Okay, that is this function. Let's go ahead and, did I do a save as? Is this one? 2 values, I did. Okay, let me edit the node properties just so it looks proper. CEE 120, this will just get it show up in the browser nicely. Oops. And get 2 parameter values. Okay, we have this one all set aside. We are ready to go through and use it. Okay, here's get Revit model values, non-recursive single value. We want to use our new one instead. So what do? We go out there and grab it. Looks amazingly similar. What I usually do is just kind of put it right next door for a minute and then start doing the wiring. Family instance, value to test, parameter to change. Oops. Actually, value to test doesn't have a value. That's the one where we're going to kind of pop it in there. That's the value that we want to keep on changing. The parameter to change is top rotation. Parameter report is floor area. Parameter report 2 is surface area. They're both areas. I'll pop that in there. And then finally, file path to write. Now, the eagle-eyed amongst you will recognize that parameter 1 and parameter 2 might have been 2 different types. So it really would be more proper to kind of say that each one's either an area or a volume. In this case, they're both area. So I'm sort of doing a little bit of a shortcut here. But we now have that node all wired up. If that node is ready to start doing the evaluation, what we need to do is just say, great, in this for each loop, evaluate that node instead. And we'll be in good shape. So now we have something that went from a single node to 2 nodes. Okay, we can save this away. And the same sort of thing will work if we need to do 3 or 2 parameters. If we need to do 3 parameters or 4 parameters, we can kind of just keep on going. So again, let's just go ahead and run this thing. we'll go through and let me just save that away. Kind of just run it and give it a test. Again, let's take a look at the values and we can kind of talk about it as it's doing its thing. So let's just run it from up to 0 to, or 20 up to, let's go up to like 150 again, something like that. Okay, it's going to sit there and do its work in the background. Okay, so let us talk about this issue of, great, we got these two different values. We have in our list, we have all the rotations. We have the floor area. We have the surfaces. Okay, and we have all these different values in each of these different columns. The question becomes really, how do we pick, given that we have these two different things? If I wanted to just sort of pick strictly the best floor area, I could pick out of that column. If I want, I can pick strictly out of the surface area, I could pick out of that column. It's really, how do we go through and try to come up with an optimum that considers both those different things? And this is where it gets kind of interesting, because this is all about really just what your optimization strategy is. Okay, one very simple way that some people will do is, we could do funny different things based on, how to combine different values. Yeah, as I start thinking about adding or working with those two different values, there's sometimes when you really want to add values together. You have something that you consider additive. There's other times when you want to multiply things together. If somehow there's a multiplicative effect where you want to sort of see, like all the different factors, how they add together to kind of come up with a combined factor. Or in this case, what I'm going to actually propose is really more of a ratio. And what I'll think of that as is an efficiency factor. So if the scenario of what I'm trying to drive is if what I'm trying to do is say, hey, great, given all these different rotations, I can get different floor areas and different surfaces. If I would like to get the maximum floor area for the least amount of surface, okay, and that's kind of that's an efficiency sort of thing. Okay, what I can do is just basically take those. So take all these. This is column 0. That's column 1. That's column 2. I can just basically go through and say, let us go through and just divide 1 over 2, okay, and make that column 3. Okay, just compute some sort of ratio over there. And that's really where we would go next. So given these two different values, as computed right here, you sort of say for all the different variations there are the different values from the floor area and the surface area. If we wanted to go through and compute all those, we can. And mathematically, you and I can do that pretty easily. It's a little messy, but we can go through and do that and figure out what we think the best ratio is. But better yet, just to go ahead and let Revit do it for us, let Dynamo do the work. So let's close that up and show you how that works. If you go through and open up the third example, come back over here to 13.3. You'll see we actually put that together for you. So in 13.3, we're basically finding the maximum minimum of a computed model. And let's just kind of show you what the endpoint looks like, and then we can go back and take a look at it. So in terms of the endpoint, here's what we did. Up front over here, we still have all this stuff. We're just getting 2 Revit model parameters. We're pulling all that together. We're just grabbing all those, going through different rotation. Okay, that part's looking pretty good. At the tail end over here, let me go ahead and run this for you here. what we want to do is basically go through and do a calculation between those different values. Let's let that run for a sec so I can get the values. Okay, it's going to go through all the different little variations. Okay, but what I want to do is grab the different values for each of those different things and really go through and say, I've got column 0, I got column 1 and column 2. Can I go through and on every different row, can I grab a single row and say, great, for row 1, can I get the value in column 1? Can I get the value in column 2? Divide those two things together and put them into column 3. Okay, because I could do that on the fly, but if I store them as a column 3, then I have a nice list of values I can go back and kind of interrogate and kind of find different things from. Okay, and let us see what it comes up with. Okay, beautiful. So here's the idea. We're over here. We got this big old list of values here. Again, the test values, the values from column 1, the values from column 2. What I want to do at the tail end of that is actually just go through and do a little calculation. And here's what I had in mind. I put together a little function which really just computes the ratio between two different columns. So I give it basically some sort of a numerator column and a denominator column, and I feed it a list, and out of that, I compute a ratio between the two. So the idea is, okay, what I'm going to do is feed it the list. I'm going to feed it the list of all the different points for all the different rows. For the index of the numerator, if I want the numerator for this ratio to be the floor area, that's going to be column index 1. If I want the surface area to be the denominator, that's going to be column index 2. That's why I'm feeding it the 1 and 2 here. Okay, and what this is basically going to go through is just go through and compute a value for each of those different rows. Just so you can sort of see what it does, let's edit it. It says, given a list and a specific row number, basically grab different elements, grab element number 1, grab element, in this case it's going to be number, or element 0, element 1, element 2. That's grabbing each of the different columns together. It says, great, let's just divide the thing in column 1 from the thing in column index 1 to the thing divided by the thing in column index 2. And basically, it's recombining a list together. So this is almost like, Natasha, what you were asking about with the strings, where I sort of took it apart and had to add it back together. So what's happening is each of these different rows is essentially a list of values. Okay, from the list, I get element 0, element 1, element 2. I do the calculations on element 1 and 2, and then I put it back together saying 0, 1, 2, oh, and throw element 3 at the end. Okay, and that's how I create another column. And I return that as the row with the ratio in column 3. So with all that stuff together, what it does is it takes this map function, and for all the different rows, starting with the first and going all the way to the number of rows, okay, just does that and returns for us it's basically a list. Let me zoom in up in that. Where for each of the different rows, here's the first iteration. For 0.34 radians, it's 203 divided by 139. So it has a ratio of 1.46. We can go looking all the way down there at all those different ratios. And it's interesting. As this went through and worked, let me just kind of show it to you in a watch. It's a little bit easier to see. If we just watch column 3, that's the ratios. You can sort of see here's the range of values. And in terms of the floor area to that, it looks like 0.34 radians is not quite as efficient. there actually is some sort of peak efficiency. It is somewhere, again, right around in here, the 1.56. So if I really look at this issue of the surface area kind of to the volume and multiply that out, okay, so it's right around there. What's happening here is we're just pulling that high and the low values off, and then ultimately setting it based on the high value, so the biggest efficiency. So what that's doing is back over here, saying again, 130. So it's kind of interesting to me about how this works in terms of this being a single tapering column, the constant twist, you know, the kind of constant taper in terms of what's going up. You know, what I would love to do to start at this, you know, either confirm or deny my intuition about this. I'm sort of intrigued by the notion that the 120, 130 degrees keeps on coming up being fairly optimal. And it probably has a lot to do with the shape and the degree of rotation here. I would love to now go ahead and keep on tweaking different things about that. Try it with uneven twists. Try with different amounts of bowing in the middle. You know, just really come up and see, you know, how much variation do we get in this in terms of, you know, whatever constraints we want to go ahead and put on this tower. We now have some ability to go through and figure out the optimal shape based on these two factors. Okay, but just to really, you know, see how much we can get that to vary based on different things we do to play around with that shape. Because, yeah, the fact that it comes up with 120, 130, that's interesting, but I don't want to believe that's always the answer. Now I'm intrigued about really how can I get it to be something other than that? Really, what sort of factors about the shape would encourage a different kind of amount, a degree of twist, something like that. So that's where we'll keep on going next time. So for next time, where we are going to go and where you're going to go is, okay, you've done this. You could figure out sort of this issue of the area. You can figure out the volume. We can put a ratio together and do a really simple little optimization. The next step will be, let's take that and say, great, okay, what if in addition to that, we started thinking about, well, the surface we're creating is kind of interesting. What if we thought about the directness to the sun of the panels that would be on that surface? Okay. So really, is this a good solar radiation surface or is it not a good solar radiation surface? And that'll have an effect on really how much twist we like. We'll also go ahead and consider what would happen if there actually was something that you wanted to look at, like the Statue of Liberty or a specific landmark, and how well will the offices in this building be able to address that? Okay, so we'll throw a couple more variables in here that, again, it can go through and iterate and evaluate all those different criteria. We'll say, given then that we have like, 4 or 5 different criteria, you know, how can we then go through and add those different criteria together to figure out what we think the optimum shape is? And again, that's very subjective based upon, you know, maybe we'll give ourselves the ability to kind of, you know, put a greater weighting on different factors, you know, so that we can get our answer really, no matter what our client says is going to be their most important factor, we can automatically get back and see, okay, what the effect of that would be on the shape of the tower. Okay, beauty. Let us adjourn there for today, and we'll see y'all on Tuesday.